Chapter 3, linear systems. A linear system is right here. 2 equations. There are 3 ways of solving them: by graphing, substitution, or elimination. So by graphing, in order to do it by graphing, here's the 2 graphs. Now the first one's right here. You begin at -1, you move up 2 over 1, the slope, the y-intercept. So the -1 and then up 2 over 1. So if you begin at -1, it's this one, the green one, and you go up 2 over 1. So that's the green line. The second one I rewrote. You try to get y by itself. And this one begins at -2, like the black one right here, and has a slope of 1. And you'll notice they hit right here at -1, -3. That's the answer. The solution to a system of equations graphically is the point where they cross. If we do substitution method, here in green is the bottom equation. The red is the top equation plugged in for y on the bottom equation, because this equals y, so I can replace y with 2x minus 1. And that's what I did. Now a lot of people make mistakes solving this. See that negative? It actually distributes, so that becomes a positive 1. And then you just solve. Once you get your answer, you then take this number, plug it back into either one of these original equations. The top looks easiest. So I plug -1 in for x. I get y. Now I have x and y. I have my coordinate, which should match this, because we're getting the same point of intersection, just using a different route. It's called substitution, called graphing. The third method is elimination. And the goal on elimination is to get it so you have x's, y's, and numbers all lined up. So I went over here. It looks like I rewrote the first equation. I minus the 2x over. So I minus the 2x over. So I have the x's, the y's, and the numbers. And when I add straight down, do you see how they cancel? Leaving you -x and 1. And I solve it. Once I solve it, I plug -1 into either one of these equations, the first or the second. Either one of these. I chose the bottom one. So when I plugged it into the bottom one, I solve it, I get -3, which the answers match for all 3. They should match. You're just solving the same thing 3 different ways. This is the basic premises of Chapter 3, systems. Now the thing next is you have inequalities. This word inequalities, it's when you have greater than and less than signs. And what happens is you graph both of them and you shade. See a shaded region? You have dotted and solid lines. For instance, this graph is ready to graph, starting at 3, slope is -1/2. Okay, down 1 over 2. It's dotted because it's just greater than. It's shaded above. See the shaded region is above the line? Because it's greater than. And it's dotted. Here, when you rewrite this equation, do you notice the sign flipped? Because we divided by a negative. Sign flipped. This one starts at -1 and goes up 2 over 3. Up 2 over 3, -1. It's or equal to, so it's solid. It's less than, so it's below. Since we're above the black line, below the red line, do you see how this little area is what's shaded? Be careful about dotteds and solids. Now, this has a whole bunch of answers. Any answer, any coordinate in the shaded region is true. Everything outside the shaded region is false, is not true for both equations. So you got inequalities and you got equations. And then lastly, you have 3 variable equations. These get a little crazy. You got first, second, third equation. From that, I took my first and second and found my fourth using elimination. But this is my first equation, but my second equation, I multiplied, looks by -2. I multiplied everything here by -2. This one right here, I took my second and third, and it looks like my second stayed the same, but I multiplied my third one by -1. And when I do that, the x's disappear for both of these, and I get a fourth equation and a fifth equation, both with x's missing. Now I take my fourth and fifth equation and solve that with elimination. Now the thing is, how do I cancel my z's? Well, this is a z, this is a 3z. I multiplied this one by -3. See, I multiplied this one right here by -3, all at the pieces. That's the top. The bottom stayed in the fifth equation. These cancel, solve for y. Once you have y, you plug y into either the fourth or fifth. I chose the fifth. This equation right here. Plug 2 in for y. Once I solve this, I get 0 for z. Now that I have these two, I plug those into your second equation. I just chose the second. It doesn't matter which one of these three you go for. I chose the second. I plug those two values in, solve for x. I have x, y, z. It's a coordinate. Just like these are coordinates, this is a 3-variable coordinate. You got to get your fourth, your fifth equations first, then solve your fourth and fifth, and then you start plugging your answers in backwards to start working your way back to the answer. Hopefully this helps. Again, systems 3 different ways. You have inequalities here and 3 variables.